Practice problems for evaluating and graphing functions. My input is 0, so I'm looking at f at 0, which is 2 times 0 minus 4, which is negative 4. My input now is 1, so I'm looking at f at 1. 2 times 1 minus 4, $2. I spend 4. I'm now in the hole 2. Plugging 2 into my function. There's the notation. 2 times my input of 2, subtract 4. 4 minus 4 is 0. Plotting the point. Notice my x position is 0. My y position is negative 4. 1, 2, 3, 4 in the y. Plotting the first point. Plotting the second point, which has an ordered pair of 1, negative 2. 1 in the x, 2 in the y. And the third ordered pair, an input of 2, produce an output of 0. Input 2, so 2 in the x, 0 in the y. Again, I have this line, linear function, if I was to continue to plot points. This function is going to look a little bit different. If you notice there's a square there, an exponent. When I plug in negative 1, be careful when you square negative 1. If you try it on the calculator, it's most likely going to give you an incorrect answer. You need to put parentheses around the input, which is all of negative 1. Negative 1 squared is 1. 1 plus 3 is 4. Plugging 0 into my function, 0 squared plus 3 is 3. And plugging 1 into my function, my input is 1. 1 squared plus 3, 1 squared is 1. 1 plus 3 is 4. So plotting my ordered pairs, negative 1, 4. Negative 1 in the x, positive 4 in the y. 0, 3. 0 in the x, 3 in the y. And the last ordered pair, 1, 4. Inserting 1 and plotting 4. Now we only plotted 3 points here to get this U shape. Oftentimes 3 is not enough, as you'll see in the next example. Plugging f at negative 3 into my function. Negative 3, all of that cubed, plus negative 3, all of that squared, minus 6 times negative 3. Well, negative 3 cubed is negative 3 times negative 3 times negative 3. 3 negatives produce a negative. Multiplying these first, I get a positive 9. 9 times negative 3 is negative 27. Then I need to add negative 3 squared, which is 9. And then I need to add 18. I'm adding 18 because I'm multiplying two negatives. 18 and 9 is positive 27, and a negative produces an output of 0. F at negative 2. Negative 2 cubed plus negative 2 squared minus 6 times negative 2. Negative 2 cubed, again, is a negative 2 times a negative 2, which is a positive 4. A positive 4 times a negative 2 is a negative 8. Negative 2 squared is 4, and a negative 6 times a negative 2 is a positive 12. 12 and 4 are 16. A negative 8 plus 16 is 8. F at 0, plugging 0 into the positions and cubing, squaring, and multiplying 6 by 0, output 0. F at 1, 1 cubed plus 1 squared minus 6 times 1. 1 cubed is 1. 1 squared is 1. 6 times 1 is negative 6. 1 plus 1 is 2. 2 minus 6, $2. Spend 6. Output is negative 4. And the last input, f at 2, 2 cubed plus 2 squared minus 6 times 2. 2 cubed is 8. 2 squared is 4. 2 cubed, 2 times 2 is 4. 4 times 2 is 8. 2 squared, 2 times 2 is 4. Negative 6 times 2, or minus 6 times 2, is subtract 12. 8 plus 4 is 12. 12 take away 12 is 0. Let's plot these ordered pairs. When I input 3, we got out 0. So negative 3, 0. Negative 3 was my input. 1, 1, 2, 3, and I got out 0. When I plot the point negative 2, 8, negative 2 in the x and 8, this only goes to 5, 6, 7, 8, so it's going to be someplace up in this location. Third order pair is 0, 0, which is the origin. Fourth order pair is 1, negative 4, 1 in the x, 4 in the y. And the last order pair is 2, 0, over 2, up 0. I've got this kind of jagged points here, but if I move from left to right, notice my points increase from left to right. I'm going to start at my first point, go up to connect to my second point, go down to my third point, to my fourth point, and to my fifth. And as we know, we could continue plotting these points, and what's going to happen is my graph is going to continue in these two directions. So it's an up-down kind of graph, much different than the first one that we graphed for practice, which had a power of 2, and the one before that with the power of 1. So power of 1, x, x squared, and then x cubed.